Now let us discuss problem number 7. In a game, players attempt to score a goal by kicking a ball into a net. The probability that Lino scores a goal is 0.4 on any attempt, independently of all other attempts. The random variable x denotes the number of attempts that it takes Lino to score a goal. Find out probability x equal to 5. Now, when I'm saying probability x equal to 5, that means I have to find out possibility that x is what? X is number of attempt that it takes. So I have to find out the probability that it take 5 attempt to score a goal. So it take 5 attempt. That means on the 5th attempt, here Lino scored a goal. So on the 5th attempt, now this is a case of geometric progression. That means on the initial 4 attempts, on first 4 attempts, he did not score a goal. So the possibility of that is 0.6. Now in 4 attempts, he did not score a goal. And on the 5th attempt, he scored a goal whose possibility is 0.4. So here the result is 0.6 power 4 times 0.4. 0.6 power 4 into 0.4. The result is 0.0518. Okay, up to 3 significant figure. This is the result. So it is 3 significant figure. Now, if we look at the probability of x equal to, so in the first instance, it seems that it could be a problem of binomial distribution. But if you read carefully what is x representing, then you will understand that this is not the binomial distribution, but this is the geometric distribution. Now find probability of x greater than or equal to 3, less than or equal to 7. Now here again, as this is a case of geometric distribution, I will say that this is same as possibility of x less than or equal to 7 minus possibility of x less than, it is said greater than 3, so it is less than 3. It is less than 3. Okay, now understand, when I say possibility of x less than or equal to 7, so it will include everything below 7. Now I have to find out possibility of x more than or equal to 3. So what I will do, I will subtract from this possibility of x less than 3, or I will say that less than or equal to, better I will say that less than or equal to 2. So here this is your 1 minus, now possibility of not scoring a goal is 0.6, so it is 1 minus 0.6 power 7 minus, here it is 1 minus 0.6 power 2. Okay, so if I open the bracket here, it will become 0.6 power 2 minus 0.6 power 7. So let us do the calculation. 0.6 power 2 minus 0.6 power 7. Okay, so the result is 0.332. The result is 0.332. Now the next part of the question. C. Find the probability that Lino scored his second goal on or before his 5th attempt. Now on or before 5th attempt, it means that either your score is on the second attempt, second goal is scored on the second attempt, or third attempt, or fourth attempt, or the 5th attempt. So here I will say that the second goal scored on, here I will say that second goal is scored on your second attempt. Second goal is scored on your second attempt. It is now if you are attempting, you are scoring second goal on the second attempt, that means you already scored a goal on the first attempt and also on the second attempt. So this is 0.4 power 2. Similarly, if I see that third attempt, now for third attempt, there is one attempt where you have not scored any goal, and there are two attempts when you scored a goal. Now these things can be arranged among themselves in 3 factorial divided by 2 factorial ways. 2 factorial ways. 2 factorial times 1 factorial, I should say. Now on fourth attempt, if it is fourth attempt, then 0.6 square, and here it is 0.4 square. Now 2 terms of 0.6 and 2 terms of 0.4, if I see, it can be arranged in 4 factorial. So it can be arranged in 4 factorial divided by 2 factorial times 2 factorial. So this is 4 factorial divided by 2 factorial times 2 factorial. And on the fifth attempt, if I see fifth attempt, okay, here I might be making one mistake. Here it is not 3 factorial divided by 2 factorial. Actually here it should be, here let us understand this. Here it should be 2 factorial divided by 1 factorial, that is 2 factorial only, and here it is 3 factorial divided by 2 factorial times 1 factorial. Now see why I am saying so, because you have 1, 2 and 3 and this 4. Here I am talking about this line. I am talking about this fourth attempt. So in fourth attempt here you are scoring, so it is 0.4. Now in these 3 places you have 2 values which are 0.6 and one value which is 0.4. so if I see all the possible arrangement, so it is going to be 3 factorial divided by 2 factorial, because 0.6 0.6 they are similar. For that it is 2 factorial times 1 factorial, so that I can say that 3 factorial divided by 2 factorial. Similarly for fifth attempt, it is 0.6 cube. Okay, so 3 attempt will be where I am not scoring, and in 2 attempt I am scoring. So 0.6 cube times 0.4 square, and here I will say that this is equal to 4 factorial divided by the, in 4 factorial divided by, it is 3 factorial times 1 factorial. Okay. So let us see their calculation. So here let us divide them in columns. Now 0.4 square, it is 0.4 square, it is 0.16. Then 0.6 times 0.4 square times 2 factorial, that is 2, it is 0.192. Then 0.6 square times 0.4 square times 3 factorial divided by 2 factorial, so that is 3, which is equals to 0.1728, 0.1728, and next I have 0.6 cube, 0.6 cube times 0.4 square times 4. So it is 0.138. It is 0.1382. Let us take 2. Okay. So total, if I see, total I have 0.16 plus 0.192 plus 0.1728 plus 0.138 1382. So total is 0.663. Total is 0.663. Okay, now we have one more question here. Lino has 75 attempts to score a goal. Use a suitable approximation to find the probability that Lino scores more than 28 goals but fewer than 35 goals. Okay, now what is the possibility of scoring a goal? If I see, possibility of scoring a goal is 0.4. So here I will say that my P, possibility of scoring a goal, is 0.4. Your N is 75. Now your possibility is very close to 0.5 and N is large and is more than 50. So here I can approximate my distribution as normal distribution. For normal distribution, my mean mu is going to be NP, which is equals to 0.4 times 75. 0.4 times 75 is 0.4 times 75. The result is 30. And then I have a variance sigma square. Now sigma square is NPQ. So here it is 30 times. Now 30 times it is multiplied by 0.6, 18, which is 18. So I will say that your X follows normal distribution with mean as 30 and variance as 18. Now I have to find out possibility that Lino score more than 28. So I have to find out possibility of X more than 28 and less than 35. Now the distribution itself is not a normal distribution, but we approximated a binomial distribution to normal distribution. So what we do, we will apply the continuity correction when I convert my X to Z, when I convert my discrete variable to a continuous variable. So I will say that probability of Z, it is greater than, now 28 is not included, so I will say that it is greater than 28.5. It is 28.5 minus mean is 30, so 28.5 minus 30 divided by your sigma is root of 18, and this Z is less than, now 35 should not be included, so it is 34.5 minus 30 divided by the square root of 18. So this I will say that probability of here your Z will be more than, now 28.5 minus 30 divided by root 18. So this is minus, this is minus 0.35, 0.3535, 0.3535, 0.3535. So your Z is more than this and it is less than 34.5 minus 30 divided by root of 18, which is equals to 1 point, it is 1.06 0.07 I will say. Okay, so this is equals to, now here diagrammatically if I see, this is your normal diagram, and here you have to find out possibility between these two limits. So this, you will say that this is, according to diagram, this is phi of 1.0607 minus, here I will say that it is 1 minus phi of 0.3535. Okay, so this is equals to, let us see your normal table, phi of 1.0607, 1.0607, 1.0607, so that is rounded to 1, so it will become 0.8556, 0.8556 minus, here it is 1 minus 0.3535, so 0.35 and 35, so I will see 4, so 63, 68, 63, 68 plus 15, it will be 63, 83, 63, 63, 0.6383. Okay, so this we will see it is equal to 0.8556 plus 0.6383 minus 1, so result is 0.4939, 0.4939. This is your result. Okay, so your possibility of x, so if I reduce it to 3 significant figures, I will say that 0.494. So 0.494 is your answer in 3 significant figures. Okay, so let us revise this question. Your D part was an approximating distribution, where your binomial distribution is approximated to normal. Now the condition to approximate your binomial distribution to normal is that your number of trials should be large and the possibility of success should be near to 0.5. Now part A was a geometric distribution, part B was also a geometric distribution, part 3 was some condition given, like your probability of Lino scored his second goal on or before the 5th attempt. So second, third, fourth, fifth, all different what we say that different cases we have to consider. So I will say that the problem related with different cases, and finally your D, where we use the approximating distribution. So this is your final question of this paper.